Hi, welcome to the EEVblog, an electronics engineering video blog of interest to anyone involved in electronics design. I'm your host, Dave Jones.
Hi, it's product review time again, and not just any product review, because I'm super excited about this one. Why? Well, not only is it an oscilloscope, a brand spanking new one, but I've got a world first. Nobody else has this. I'm the first to review it. So, what is it? It's the brand spanking new Agilent 2000 series oscilloscope. Oh, check it out. Isn't it just beautiful? Look at that. Yes, it definitely is sex on a stick, and it comes out today. And thanks to Agilent, I have one of the very first units to roll off the production line. So, let's check it out. Now, Agilent makes some really bold claims about this new low-end series of scopes they got. It's actually two series. It's the 2000 series, which is this one, and the more upmarket model, which is the 3000 series as well, which I've also got, but you'll see that in another review. So we'll stick to the 2000 for this one. Now, this is their new entry-level scope, designed for, hobbyists, university teaching environments, people on a budget. And they claim that it actually redefines oscilloscopes. It redefines the entire market. It's a bold claim. Does it live up to it? Well, we'll find out. But it is very attractively priced. It's got some rip-snorting new technology, and best of all, it's designed and built in-house by Agilent. That's right, no longer are they rebadging the Rigol models, because everyone knows that the 1000 series Agilent oscilloscopes were just their low-end, their existing previous low-end model were just rebadged Rigols. And, well, that was always curious. Everyone was saying, oh, why did Agilent do that? Just rebadging some, cheap Chinese brand oscilloscope. What are they doing? They've lost the plot. All that sort of stuff. Well, I reckon, though I don't know, but I reckon they were probably just doing that to bide their time while they were designing this baby, because this is completely in-house designed and manufactured by Agilent. The ASIC, which is used in here, which we'll go into, designed in-house by Agilent. That's the heart of the new technology, manufactured in Agilent's plant in Malaysia. It's got nothing to do with Rigol or any other one. They've gone back in-house, and I love it. Now, the new 2000 series model is the Infiniivision model. So, Agilent are now going to brand all their oscilloscopes Infiniivision across the entire range. And because of this new technology which enables better performance at a lower price point, it means that there's lots of overlap with their existing oscilloscope models. So they're going to drop not only the Rigol 1000 series, of course, they're going to drop their 3000 series and their 5000 series models as well. So all their models from now on will be Infiniivision technology, and so you'll have the 2000 series, the 3000 series, the 6000 series, and so on, right up to into the stratosphere, the ones that cost the same as a new house. And one of the claims they make with these new models is that they're the industry's first fully upgradable oscilloscope. So you buy your entry-level model, which is the 70 megahertz model, 2 channels with no logic analyzer, no anything else, no options, and then you can option it up to the hilt later through not hardware upgrades, but actually software upgrades. You guessed it, everyone's doing it these days, these software upgrades. So you just, feed your credit card number on the internet, they give you a license code, you plug it in, and the option's enabled. That means that the base model you buy actually has all of the hardware actually built in. It's got, which we'll go into, the new waveform generator. Super excited about that. The logic analyzer, mixed signal capability, the 4 channels, everything is all, and the bandwidth as well, is all built in, and it's just purely a software upgrade. Now, it comes in 3 different bandwidth versions. The base model is 70 megahertz, then 100 megahertz, then 200 megahertz, and quite frankly, I don't know why they bothered with the 70 megahertz version. What's with that? Why not just make it 100 and then 200? Bit stupid. Anyway, all the models come standard with 2 gig sample per second. And of course, it has a mixed signal capability. It's got the logic analyzer down here, which is 8 channels. It's 16 channels on the 3000 series model, the totally different series, the upgraded one, but this one's only 8 channels. A little bit disappointing, but it is mixed signal capability, which is awesome. Pretty standard in scopes these days. But one of their huge features is a waveform generator output, and we'll go into that in much more detail later, but that's super exciting. The first scopes on the market to have a waveform generator output. And all the models come standard with 100 kilobytes of memory, which isn't as much as some of the low-end scopes on the market. They're all going to 1 meg or 2 meg sample memory, but the reason this one's only got 100K is because the update rate, and this is the huge selling point with these new series, the 2000 and the 3000 series, the waveform update rate is incredible. It's 50,000 waveforms per second. Oh, for a $1,200 oscilloscope. You gotta be kidding me. So that's really the main selling point of these new scopes. They've got phenomenal update rate capability. They're super quick, which previously you wouldn't have got that sort of speed unless you paid $5,000 or $10,000 for a scope. So to get this in their bottom of the range 70 megahertz unit for $1,200 is just phenomenal. It's game changing. Now normally at this point I'd get so excited that I wouldn't turn it on, I'd take it apart. But I won't do that in this review because I really want to save that for its own separate review, and I'll do a teardown of this thing properly. So that'll be in the next video. Now to give you an idea of the size of this unit, I've got it compared to a standard Rigol here or the Agilent 1000 series scope. And as you can see, it's up on its tilting bail here, and it is a fair bit bigger as you'd expect with the much larger display. But it's the depth of the actual unit is actually the same as the Rigol at its deepest part here. So its footprint isn't actually, there's no more extra depth to it, but it is just a bit more width and a bit more height, of course. Height's not a problem because it doesn't take up extra footprint on your bench, which is what it's all about, footprint. In terms of weight, the new Agilent weighs a fair bit more. It's about 3.8 kilos. It's almost topping 4 kilos when you include the probes and everything. So it has got quite a bit of heft to it, but that makes it sit on the bench all the better. And there's the depth of it. As you can see, it's pretty much identical. It's really no deeper than a standard Rigol. When you first look at the unit, you really are impressed. Just the design and the construction quality of this thing is first class. It really is. I'm thoroughly impressed with this. The handle on the top sort of snaps into place like that. It's a really nice design. The tilting feet on the bottom are real quality, real class act. There's no issues with that at all. It's got nice big feet on it's got plastic feet on the front like this and rubber feet on the bottom like that, so it really sits on the bench very well, and you can sort of poke at the buttons without really any issues at all. You poke the ones up the top here and it doesn't really fall over. It's quite a stable unit on the bench. And of course the case designers have gone a little bit funky on this. It's got this lovely curved side on it like that, and it just looks really brilliant. It is sex on a stick. It's got this nice little cutout area like this, and as you can see, it's got a USB device interface for hooking up the PC. It's got a second USB host for a USB stick. It's got one on the front, so that's just a duplicate. You can put it on the back to not sort of clutter the front, so that's a nice design aspect. It's got trigger out for the function generator. It's got an external trigger in. As you'd expect, there's a calibration thing there. I'm not actually sure what aspect of the calibration that takes care of. And on the back here is a key lock mechanism, so you can actually stop people stealing it. I don't know how well that works. And there's a little pop-out module like this, and you can actually buy external modules for this. Now, I was quite disappointed by this. This is actually a LAN and a VGA interface module, and this is optional extra, of course. It doesn't come with it, and it just plugs in like that. It's really nice, but I was quite disappointed that the LAN and the VGA functionality weren't actually built in to the scope. And I believe the only other module you can get for it is a old school GPIB. So if you want to run some legacy gear, not a problem. And on the back here is a large fan, which is actually angled sort of to come out the side like that. And it really is whisper quiet. I'm very, very impressed by the low noise output from the fan. And of course, as one of the huge features of this scope is the incredibly large screen. It's one of the largest in its class, especially on these economy scopes. It's 8.5 inches diagonal. It's WVGA, which is 800 by 480 resolution, and we'll take a look at that in a minute. But the layout of the unit is quite conventional. You've got your 4 channels here. If you only buy the 2 channels, then only 2 are functional, but you will get 4 with it. And you've got the separate vertical controls, which I love. I hate scopes which have just a single vertical control, like on the Rigol, the 1000 series Agilent. It's got the single vertical input and you have to select between them. This one's got the 4 separate ones. One of the things I immediately noticed is that they didn't actually line up with the connectors down here. And I thought, that wasn't that great a design decision. But I guess you have to, it's a trade-off between the total length of it and the fact that you've got this huge screen on there and you have to space out the connectors, etc., etc. So I guess that's just a minor little quirk that I noticed. One of the nice aspects of the input connectors is that they're actually fully color-coded. So yellow, green, blue, and what's that, sort of like an orange type color to color code the actual channels, and that will reflect on the screen as well. So it's really easy to identify your individual channels. And the rest of the control layout is a little bit crowded, but it is organized quite well and it is quite functional. You've got your trigger settings here, you've got your measurement settings in the center, and over here you've got your special functions for your serial decode, your digital mixed signal channels, your math, and your reference waveforms, and they've got their own convenient vertical and select buttons as well. And your horizontal is all up here in the section. You've got your horizontal zoom, your delayed time base, a search capability, which is not on this one, and navigation as well, which we'll go into, and your traditional run, stop, single control buttons, default setup, and auto scale, which is sort of buried down in there. Now, one of the things I like about the auto scale on this thing, I'm anti-auto scale because it means you cheat and you don't use your oscilloscope properly, especially for students. You can actually disable that in the firmware. Teachers can actually turn that off so that the students can't, while the teacher's got their back turned, can't just press the auto scale button and get it to all work. A great little feature. And all of the buttons are pushable as well. They all have a secondary push function, which is really quite nice. And they've got an excellent feel to them. They've got like a rubber outer surround on them, and they really do feel like quality controls. They're all optical rotary encoders, of course, and I like it. It just gives you a real sense that it's designed well, and they're using quality components, quality plastics, quality rubbers, as you'd expect from someone like Agilent. And along the bottom, because this is a mixed signal oscilloscope, we've got a standard 0.1 inch IDE type interface, which uses the standard Agilent probes. We've got a USB key host on the front. Interestingly, we've got Demo 1 and Demo 2 outputs, which we'll go into. They're not just standard calibration signal outputs, and the huge selling feature on this one is the optional signal generator output, which we'll go into in detail as well. And it's got a real manual push button, which actually turns off the mains. It's got 6 soft buttons along the front with your back key here. So the overall interface is actually very nice. I like it. It's well laid out, it's well designed, and I'm impressed. The input connectors on the 2000 series don't have the smart connector interface, the smart probe interface. That's only on the 3000 series model. And here's an interesting sticker on the back which tells you a lot. It tells you it's running Windows CE 6.0. Now, that's nothing to be scared of. I know you might think, oh, Windows in an oscilloscope, oh, it's horrid. But really, you don't notice it. And for such an incredibly complex instrument like today's modern scopes, you really do need a proper operating system like Windows CE to run it. One really nice aspect of the scope on the top is this little enclosure here. You pop it open and that's for your probes. I really like it. Nicely thought through. But it fits 2 probes rather nicely. There's 2 probes in there plus the accessories, but does it fit 4? Let's try it, because this is a 4-channel scope. Geez, that was tough, but I don't know. It's a bit dodgy. You can just fit 4 probes in there if you try. And what do you get in the box? Well, you get the standard probes. Now on the 70 and the 100 megahertz model, you get 150 megahertz times 10 passive probe, but because this is the 200 megahertz model, you get the 300 megahertz times 10 passive probe, and it's quite nice. It comes with the usual adapters, and it comes with a bag of bits. You've got the alignment tool, you've got a B&C adapter, which is quite nice. You've got all the color-coded things to match the front panel. You've got 2 extra probe tips, plus you've got the low inductance ground clip as well. And you also get a calibration certificate, which is fantastic. It actually comes with the actual sticker, so you can put the next due date on there and actually stick that on your scope. Unfortunately, it doesn't come with the full parametric test, so all the measurements that were actually performed, but still, for a $1,200 scope, it's great to see that you get a CAL certificate with it. And of course, if you pay your $700 and get the logic analyzer option, you get the lovely Agilent logic analyzer probes. These are, I'm pretty sure they're the same ones that are used on all their ranges of scopes. These look like the same ones I have for the 54621D that I used to have, and they're lovely. They're all numbered individual probes. They've got standard 0.1 inch pin hooks on the end, so you can plug those directly into test points. You've got some spare ground attachments and the easy hooks as well. They're very nice logic analyzer probes. And even nicer, check it out, made in USA, and the easy hooks as well, made in good old US of A. Okay, let's boot this thing up and see what we get. It does take a little while to boot up. Now, I think these LEDs up here for the run, stop and single mode, there's the new ASIC inside that's where all the magic happens. This is the new ASIC they use in their real high-end models. The same technology is filtered down into these low-end $1,200 entry-level models. It's incredible. Anyway, it's now taken it's almost 30 seconds to boot up. So it does take a little while with Windows CE, and it's got to do initialization and all that sort of stuff. So that's pretty annoying. That's just over 30 seconds. But the screen is brilliant. It's not quite as bright as, say, the Rigol unit. If you try and compare them here, it doesn't show up on camera that well, especially in low light. The Rigol does have a much brighter screen, but this one is just gorgeous. It is a beautiful display, 800 by 480, so that means there's no pixel compression in the waveform at all. Now, I think the run, stop and the single LEDs up here, they're actually a little too bright. Probably doesn't show up on camera, but in sort of lower light situations and labs, they're quite bright. So I think they might need to drop that down a bit. But anyway, minor complaint. You can, of course, basic operation is just like any Agilent DSO. They've had the very similar operation for, more than a decade now. So as you can see, this is the 4-channel unit, so we can just turn on all 4 channels like that, no problems at all. And on the display side of things, you'll see that the vertical setting is actually, they've got the same colors, so yellow, green, blue, and pink, I think it is. They match the 4 channels, so that's quite nice. And this is a permanent display down the side here. Now, it permanently shows the acquisition speed. It's currently at 1 gig sample per second. Now, this is actually advertised as a 2 gig sample per second unit, but unsurprisingly, that's in interleaved mode on a single channel. So as soon as you turn on the second channel, you'll see the 2 gig samples per second drop to 1 gig sample, but that doesn't drop any further if you turn on the other 2 channels. As far as I can find, there's no way to actually turn off this particular display panel here, so you can't, very disappointingly, can't expand the horizontal out by another couple of divisions and see more on the screen. I don't know why they chose not to disable that. I think that's bit disappointing, and I think they should probably fix that in a firmware upgrade. But that's just my personal opinion. And it would have been nice if they had soft buttons down the side here as well, because during operation I have found that several of the operations you have had to go back to the main to access the soft keys. You've had to go back into things to actually get through it. So if they stayed on the vertical soft buttons like many oscilloscopes have, then that would have been a much better user interface. But at the moment you've only got the 6 soft keys down the bottom, so everything must go through there. So if you go into the math screen, for example, then you can't still have the math screen up and go into the vertical as well. And here's an artifact of the fact that these scopes come embedded with everything regardless of what's actually in them. And 2 really annoying things, check this out, it's got serial decode mode up here. Remember, I've got the top of the line fully equipped model, and to prove that we'll go down into the help and we'll go into about oscilloscope, and here's my unit. It's got the LAN VGA, it's got all the software options, it's fully optioned up to the hilt. This is the best 2000 series model you can get. But if you hit the serial button, what does it say? Serial bus decode is not available on the Infiniivision 2000. Grrr! But they've still got the button there. Same with the search capability up here. You press search, event search is not available in Infiniivision 2000. Crazy. You've got to go up to the 3000 series model, but the buttons are all still there. One really nice feature of the vertical channels is if you want to move them back to the center, you just push the vertical adjust button and they all center. Very nice. And likewise with the horizontal shift, if you've actually adjusted the delay time of the horizontal like that, you can just push it to 0 back. And of course with the phenomenal 50,000 waveform updates per second, this thing might take 30 seconds to boot up, but it is lightning quick in operation, and that is one of the first things that you actually notice. It is very, very quick and very, very responsive, just like you'd get in a very high-end professional, $10,000 plus oscilloscope. I love it. And a quirk that's not uncommon in digital oscilloscopes, when you change the vertical division, it often has to switch in a relay and you can physically hear it, and that actually takes time to switch the channel, so you do get artifacts like that. But that's really worst. That's pretty much worst case. As you can see, if I actually plug in the waveform and I get that up and then I switch through, there's much less of a problem with that. Now, one of the most phenomenal aspects of this new scope are these training signals. If I go into help, it's got training signals and it's got auto demo signals. Now, if we go into training signals here and we call up this list here, check out all these training signals we've got, which appear on the display. We've got sine, of course, sine with noise, superimposed. We've got phase shifted sine, sine with glitch, amplitude modulated sine wave, RF burst. We've got repetitive pulses, ring-in, clock, digital burst with infrequent glitch. Unbelievable. This is fantastic for not only training, universities, schools, things like that, to teach people how to use oscilloscopes, but it's actually surprisingly handy for real-world use. If you haven't used this scope for a while, or you're trying to, for example, set up an elusive trigger for an elusive glitch or runt pulse or something like that, that only happens maybe once a day or even once a week, and you're trying to capture that. The last thing you want is to set up your oscilloscope incorrectly and then actually miss that. So what you can do is use these training signals to actually set up the trigger that you actually want, test it, make sure it all works, make sure you know exactly how you're driving the scope before you actually sit there and try and monitor and capture your glitch in your real circuit. So it has much more functionality beyond just schools and training. I love it. It's a brilliant feature. Every scope on the market should have built-in training signals. And one of the great things is you can just hold down the button over the function that you want, and it gives you info about it, what it can be used for, the application, and how to actually do it. And you can do an auto setup as well. It's just phenomenal. So if we go in here and choose, say, RF burst, and we hold down the button, it's going to tell us what that's good for. It can be used to show the benefit of segmented memory application to capture occurrences of bursts. Or if you've got, say, sign with glitch on it, then, well, there we go. That shows you how to use the benefit of peak detect in acquisition mode. It tells you exactly what signal it's going to generate. Ah, fantastic. And let's go into help again and let's choose the auto demo. So it tells you exactly how to configure the probes on there like that. I've only got one probe configured, but that doesn't matter. And you've got different options: update rate, MSO, segmented memory, mask test, waveform generation. And you can actually apply all of these items and it will auto set up your scope for you. So if we go back, exit, and say we want to test update rate, now this will tell you it generates a signal, one glitch or different waveform every 50,000 cycles. So this shows the update capability of the scope. And here's the big feature, okay? This, as you can see, we're generating this 1 in 50,000 glitch. Now this has got 50,000 waveform updates per second, so you would expect it to capture, on average, at least one of those glitches every second. And as you can see, it actually does it faster than that. It actually captures them. And if you can see it in this mode here, that it's glitching like that. And you may think, oh, well, what's the big deal? But, we'll compare it to an ordinary scope in a minute. And you can see that's the glitch waveform that it actually captures. Now, on a normal scope, to capture something like that, a really infrequent glitch like that, is incredibly difficult, especially on a DSO that only has a couple of hundred or a couple of thousand waveform updates per second. But because this has got 50,000, it's phenomenally quick. It easily captures that. And if you go in and adjust the intensity, okay, I've got it at 100% at the moment, but as you can see, it really goes down. So it works exactly like an analog oscilloscope. It's got that persistence kind of feature based on the intensity. So you increase the intensity and that line gets thicker and thicker. And if you turn it down, if you've got a little trap, if you've got your intensity down, you can barely see that little glitch. I can just see it. I'm not sure if it shows up on camera there, but now the way you normally overcome that on a normal scope to find such infrequent glitches is not only to turn your intensity up, but actually turn your persistence mode on. If your digital scope has a persistence mode, what you want is infinite persistence, like that, and as you can see, we can actually clear it, boom, and it starts building up and it doesn't erase the image on the screen. As you can see, even with a low intensity like this, if we clear it, we're still going to capture that event. And as you can actually see the noise around the waveform as well when you turn the intensity down. And that analog-like variable intensity, in this case, for this scope, it's got 64 different shades of intensity that it can actually give you. So that's like analog-like performance, which you traditionally have only gotten on extremely expensive $5,000 or $10,000 plus oscilloscopes, but now you can get it for just over $1,000. It's phenomenal. And just to show you what 50,000 waveform updates per second can do, as you can see, I've got the glitch here, and this is in real-time mode, okay? It's in real-time mode, and you can see the glitch clearly. It pops up more than once per second, so it's obviously capturing that pretty easily. I've got exactly the same signal fed into the Rigol here, or the Agilent 1000 series. Now, this doesn't specify how many waveform updates per second, but the upgraded model to this, the one you pay a lot more for, has only a couple of thousand waveform updates per second. And as you can see, I've got the intensity up to maximum there. And you can stare at that thing all bloody day and you are not going to capture that 1 in 50,000 glitch. You're just not going to do it. The Rigol, I've turned on infinite persistence. So when this is actually sampling its waveform a couple of hundred or 1,000 times per second or something like that, which I don't think this one goes that quick, but if it happens to capture that little runt glitch like that, then it should show up and it should stay on the display. Now I'm going to time that sucker to actually see how long it takes, but it hasn't shown up yet. Come on, what are you waiting for? Bingo, there it is. We finally got it. After more than a minute, it finally showed up. And I just did a second one, and it also took about a minute. So you can actually conclude that this Rigol, if you do the math, 50,000 waveforms per second in about a minute, that's just over 800 waveforms per second for the Agilent 1000 series. So this is just a simple example. Sure, you can find the same pulse in around a minute on the Rigol, but if you've got a much more elusive pulse than this, then, well, this thing, our 50,000 waveform updates per second, is really going to allow you to capture it, whereas something like a low-end scope simply will not do it. You could wait weeks or forever until the cows come home, and you still won't capture your glitch. So it really pays, it's worth paying extra to have a super fast update rate like this. Here's an example of its mixed signal capability. We've got a digital waveform which is actually generating a sinusoidal signal. This is the direct output from the DAC, and this is the filtered version here. And these are the digital signals, D1 through to D7. And as you can see, it's actually got a serial decode here. If you zoom in, it actually gives you the hexadecimal value for that particular word at that particular point. And as you can see, you can actually see, maybe you can't on the video, but you can see the shimmy, the jitter on the signal there. And it really is very, very nice. But that's the kind of thing you can do with a mixed signal oscilloscope. You can see time correlated signals between your analog and your digital channels. Now, if you press the digital button over here, these two controls become active, and they control the selection of your digital channels. So this one here actually allows you to select, it turns red, select the waveform. Now this is the standard Agilent mixed signal interface they've had for a long time, and then you can move, once you've selected the waveform, then you can move it around like that. You can change the size of them like that to take up more screen real estate if you want. And as you can see, it has different colors here for the 1 and the 0 level, and that's really handy so that you don't get the waveforms confused when you've got a whole bunch of them on the screen at once. And of course you can label them as well, and you can, it's got bus capabilities. You can set up individual buses, you can deselect, you can base information as hex or binary. So now we've got the binary information there instead of the hex, and it really is quite a nice usable mixed signal digital logic analyzer. I like it. And the label interface is the same. If you press the label button here, you can actually select any one of the individual channels, the math references or the digital channels in this case. So if we go down and we select D7, we can go in and then we can actually spell, we can select the letter, bang, something like that, and we can label it anything we like. Or we can actually, and we can apply the new label, or we can select a one of these predefined options down here. So if we know that signal is actually a clock, we can actually select clock and apply new label, and bingo, you can see that channel is now labeled clock. So it's worth, when you set up a digital logic analyzer like this, it's worth just spending 5 minutes going through labeling your signals so you know exactly which one is what. Trust me, a real trap for young players is to not label your signals. And this screen real estate I was talking about over here really comes in, really is a factor when you start looking at long time signals like digital logic analyzer signals, for example. It'd be great if we had that extra real estate to see the data off in there. One really nice feature is this transitional display down here. Now you can actually see digital signals 0 through 7, and that tells you if they're high, low, or transitioning. And that means you don't have to look at the display up here. You can instantly see whether or not there's any glitches on your individual channels, or whether or not they're transitioning, what state they're in. Really handy. One excellent feature is this auto navigation function down here. Now if you get a bunch of data on the screen like this and you stop your acquisition like this, normally you can zoom in like that and you can, you know, scroll along like that manually, but that's boring. If you're looking for something, you just hit the navigate button and you can just scroll left and right like that. So that's an incredibly handy feature. It just allows you to scroll through and your entire 100, in this case 100k point waveform memory, and actually find the data or whatever you're actually looking for. And at any point you can stop it like that, you can go back, and it's just, it's beautiful. And if you want to speed it up, you just press the arrow button again and bingo, you can make it go as fast or as slow as you want. And of course it's got measurement capability. So if you hit the measure button here, you get up the measurement menu and you can choose which one you actually want to measure. Let's say we want to measure channel number 1. What type do we want? These are the different types of measurements you can get. There's a whole bunch of them. Phase, delay, rise, fall time, yada, yada, yada. RMS things, average, overshoots, peak, min, max, boom. And you can go snapshot all as well. So let's go snapshot, and it gives us a complete snapshot of that particular data. And as you can see, it will actually track, auto track. In this case, we've got the peak to peak value being displayed here and the frequency, and you can add different measurement options as well. You can just choose the different type of measurement and it will add it to the measurement menu down here. Now, one of the things I'm quite disappointed about is the frequency counter. It's not a true hardware frequency counter like you get on, say, the $400 Rigol or 1000 series Agilent. It's clearly a software one based on the data, because if we go in here and we've got no edges, bingo, it's no edges. There's no hardware frequency counter, and you'll see the digits drop as we drop the time base like that. It continually goes down. That proves that it's a software frequency counter. Very disappointed. I expected with this new whiz-bang ASIC they would have put a hardware frequency counter in there. Of course, one of the big problems with digital storage oscilloscopes is aliasing. Now, some oscilloscopes really can't handle it at all, but this one can. And to prove it, I've got a 20 megahertz sine wave going down here, and if we turn the time base right down, you can see that it's not going to alias and give us a low frequency signal. We're at 500, we're at 1 second per division now, and it's still, you can't obviously stop that and zoom in, but it's not going to alias. So if we stop that and zoom in, it's just, it's pretty much gobbledygook, but it's not going to alias on us and give us a sine wave like you'll get on, say, the Rigol unit, so it won't fool you into thinking that you've got a different frequency than what you truly have. And just to show you aliasing here on the Rigol scope, I've got the same 20 megahertz sine wave. Okay, now let's turn down that time base, and bingo, as you can see, it gets to a point where instead of showing you just the full display, it starts displaying, ta-da, a sine wave, and you think that you've actually got a sine wave of that frequency, but you don't. That's aliasing, and the new Agilent scope doesn't do it. So that's a real trap for young players on these cheap oscilloscopes that alias. Now, if you actually stop that, look, you can even capture that, and it's 2 milliseconds per division. That's not our 20 megahertz sine wave. It's lying to us. And let's try out the network interface. I've got it hooked up to my PC here, but you can have it hooked up to pretty much a network anywhere. And if we go into utility menu, we go into I/O, it gives us the IP address. So we can actually type in, and it actually takes a bit of time to connect, but you eventually get to the web page for the oscilloscope. And it's quite a nice interface. We can actually identify the scope by hitting the identify button here, and this is good if you've got multiple scopes set up in your lab. You can figure out which one you're actually talking to. And it's a rather nice interface. You can configure the network stuff down here. You've got instrument utilities. You can look at the installed options that you've got. You can look at the firmware version. It looks like you can run some apps. You can get a screen image straight away. Bang, that's a screen capture directly from the scope instantly. Very nice. You can save, record stuff. And of course, you can fully control the oscilloscope remotely. You hit a remote interface and bang, there it is. Here's the remote front panel for the scope. So we can, trust me, it's actually, I've got the scope next to me and it is actually reflecting on the screen of the oscilloscope exactly what we're doing here. So the control layout, it doesn't actually look like the real scope. The control layout is different. The horizontal time base you can adjust. It would have been nicer if the controls actually mapped the real oscilloscope. I really don't like these where they just change all of the layout. What's the point of that? Have a real screen capture of the oscilloscope. That's the proper way to do it. But anyway, you can do everything. You can auto scale, you can do anything, operate all the menus, you can do everything you normally would with the regular scope. I like it.
Now, I'm not sure what the update rate of the connection is, but I'm actually doing that auto demo function with the runt pulse, and there's supposed to be a runt pulse there, and I can see it on the oscilloscope over here, but it's not showing up quick enough. So that shows that the refresh rate, really you can't make use of that phenomenal update rate, and I think that's a bit of a shame. Now, interestingly, that same runt pulse shows up in the mask testing. So I was going to show you this on the oscilloscope, but I'll actually show you it on the PC menu. You've got this mask capability, so you can actually define a mask around the waveform at a certain value, and this is great for production testing and things like that to make sure waveforms are within a certain specified tolerance. And as you can see, anything that fails in the grey area here actually shows up as red, and it gives you total stats too. Look, it's already done 3 million tests, shows the date and time, the failure rate in percentage, the sigma, and you can reset those statistics. So look, it's already done 100,000, bang, in a couple of seconds. That's how many tests it can do per second, and this updates via the remote interface. It's quite phenomenal. I love it. One of the remarkable things about the new Agilent scopes is that the waveform updating really won't slow down with this mask testing because of this new whiz-bang ASIC they got in there. It just, it doesn't have to do this in software. It actually can do it inside the ASIC itself. So these normally computational intensive tasks like mask testing really don't slow down the machine like they would on a traditional oscilloscope. And that's one of the main advantages of this new ASIC and these new modern scopes. I love it. And I've got it hooked up to a 22-inch external VGA display here using the optional VGA module, and it just duplicates what's on the scope. The scope display is still there, so it is a true dual display capability, but unfortunately it doesn't give you any extra screen real estate at all. It just duplicates what's on the scope, and it works quite well, no problems at all. Yet another awesome feature of this new scope is what's called segmented memory acquisition. Now, where this comes in handy is if you've got bursts of data like this separated by lots of dead period, very long dead time periods like that, which I used to have in my seismic and underwater business when I was working in that sort of stuff. You'd have like an acoustic shot here, then you might wait 10 seconds for another acoustic shot, and if you want to analyze those particular shots in detail, then you need a massive amount of sample memory, hundreds of megabytes and gigabytes of high-speed sample memory to do it. And to get a scope with that much memory costs $50,000 or $100,000, or it may not even be possible if the time periods are long enough. So let's actually give this a go here. What segmented memory does is it only captures the actual bursts of data that you're interested in, and it doesn't waste all of its precious sample memory capturing non-existent data. So let's give it a go. And this is what these individual bursts do. And you can actually cycle through each burst of data and then analyze them in detail, which was next to impossible to do this before. God, I wish I had this when I was working in the seismic industry. It would have been phenomenal. And you get this on a $1,000 class oscilloscope. Unbelievable. One of the huge points of differentiation with the new Agilent scopes is the built-in waveform generator, which is worth its weight in gold. To have a function generator built into your scope, it's so obvious and awesome, and that's built into the new ASIC. It's actually got a waveform generator built in. Now, as you can see, it can generate sine, square, triangle, pulse, ramp, all sorts of stuff, noise as well as DC signals. And it really is quite remarkable. It's got a bandwidth of 20 megahertz, which is quite phenomenal. So a 20 megahertz function generator would normally set you back $500 or $1,000. Now, unfortunately, the generator option does actually cost $500, so it doesn't actually come with the scope, and it can actually be routed through to these demo signals here, as you can see, but this main BNC output is for the function generator. So let's have a real play with it. I've got the probe hooked up to the waveform generator output, and you press the wave gen button here, and that switches on your waveform generator. And as you can see, you can select your different types: sine, square, ramp, pulse, DC, and noise. And you set the frequency fine as well, and you can adjust that, no problems at all. It works just like a regular function generator. The amplitude can be anywhere up to 5 volts peak to peak. It can go right down to millivolt region. So, and you can specify the DC offset as well. Let's go into the settings. The output load impedance can be high impedance or 50 ohms, which is important to have, of course. And you've got trigger outputs that you can set up so that the B and C connector on the back of the scope here can generate a trigger signal that's synchronized to your function generator output. It's quite nice. And if you're astute, you would have noticed that there's one thing missing from the selection of waveforms, and that's an arbitrary mode. Now, I reckon that the ASIC in here is very capable of actually doing arbitrary waveforms, and it makes sense to have. Why they didn't do this, I'll get into, but to be able to, say, capture the input with the analog signal, store it as an arbitrary waveform, and then output on the function generator, that would have been phenomenal capability, phenomenally powerful, and is the reason behind why you can buy arbitrary waveform generators that hook up to oscilloscopes. But I reckon it was a deliberate decision by Agilent. This is my guess, and my guess only, is that they deliberately decided not to put arbitrary waveform capability in there, because this instrument would be too powerful and it would eat into the sales of their function generators. And Agilent make a lot of function generators, so I reckon somebody at the function generator division had spoke in the ear of the oscilloscope designers and went, don't you dare put arbitrary waveform capability in that scope, otherwise you'll put us out of business. And it's a real shame. Agilent, shame. There's a quick action button here which you can actually set up and define. So it's like you can switch it on and you can quick measurement all. So if you want to switch down to there, let's select that. So that anytime you want, you can now just press that and bingo, up pop the quick measurements. Quite a nice function. So it's a user definable soft key. And I really like having the default setup button up here. You can actually set up the scope to a default setting and then bang, you just hit that and it goes back to what you set it up for. And that's useful for production or test environments where someone borrows your oscilloscope but you've got one favorite setting that you want. You can program in there. When it comes back, just hit the default and you're sweet. There are a couple of puzzling aspects with this scope. Now check it out. If you select the vertical menu, coupling, right? On almost every oscilloscope you'll ever use, it has AC, DC and ground coupling. Well, let's try this one. It's got DC and AC. That's it. There is no ground coupling, which is remarkable because in the spec sheet it actually says it does do ground capability, but in the manual it doesn't. So somebody put it into the spec sheet and just didn't carry through the firmware. Why they've left it out, I have no idea. And as with all decently powerful oscilloscopes, you can actually go in and define your probes, and you can actually set up not only the type, you can actually set the ratio in you can actually set it to decibels as well, the units in volts or amps for current probes, and you can set the probe skew as well. So you can actually match the probes if you've got different types of probes or you want to actually calibrate them just right. Curiously, Agilent have actually ditched the equivalent time sampling capability which you usually get in DSOs. So that's why you won't find a spec for an equivalent time sampling rate, because there is no mode to do it. It's purely a real-time digital storage oscilloscope, works in real time only. And if we go into the acquire menu over here, we can actually see that it does normal, peak detect, averaging and high resolution. Now high resolution is actually up to 12-bit mode. It doesn't have a 12-bit converter, but it actually uses averaging on the input in certain time-based modes to give you a higher fidelity waveform, and that's a useful function. And of course, as with all modern scopes, it's got math capability, which allows you to choose FFT among the other options. It's got different function types and allows you to set the span frequency and the center frequency and the different Windows types with all the usual selections. So it seems to work quite well. The update rate is quite good. But as with all FFT functions in scopes, it's really no substitute for a proper spectrum analyzer, not even close. And I know what you're thinking, with all this phenomenal update rate, what's it like viewing an analog video signal? Well, let's check it out. I've got my Kodak placeboard here generating a video signal, and let's trigger on it. So if we go to the trigger menu, and of course you can't trigger on edge triggering, you've got to have video triggering, which it does. Bang! It locks straight in.
And bingo, there's your video capability. It's actually quite nice. You can trigger off NTSC, PAL, CCAM, and all the different fields, alternate, field 1, field 2, all that sort of stuff. You can do field hold off, and it works really nice as you'd expect from a fast update rate oscilloscope. And you can choose your individual line number here, so I can scroll through those line numbers, and then that's a static image, and then if I start the image, bang, there it goes. That's actually playing back a video. And as you'd expect with the USB capability plus the networking interface, it can print to a various items. So we go down to save recall, and you can go format setup. You can get 8-bit bitmaps. You can get PNG file, which is really nice. You can export the data in CSV format. All sorts of different things, mask data, binary data, and somewhat curiously, if you hit the print button, that actually is network printing. So you've actually got to set up network printer capabilities. If you want to save to a USB stick like this, you've actually got to go into save recall, and then you've got to go press to save, and bingo, it saves it to a PNG. And let's check out the baseline noise performance. Because it doesn't have ground coupling on the input, I've disconnected the inputs here, and the probe is 1-to-1. So as you can see, 2 millivolts per division. It's basically got 1 full division or 2 millivolts of noise. But if we go into the acquire menu, that's in normal mode. If we actually go into averaging mode, of course it takes it all out. But if we go into high resolution mode, it's about half that. It's about 1 millivolt. And you can see that difference even at 1 volt per division. Yeah, noise is actually quite significant there in normal mode. If we go into high resolution mode, it's much better. One extra benefit of using the high resolution mode here is that it actually makes use of the samples when you're at a lower time base like this and a lower sample rate. It uses all those dead samples that it would normally throw away. It would normally decimate those samples because it's a 2 gig sample per second converter. It always samples at that, but because it's only filling up the memory at 250 meg samples per second, it's throwing away all those extra samples, whereas the high resolution mode can actually make use of those, and it does that inside the new ASIC, so you don't actually pay a performance penalty like you would in a regular oscilloscope that has a high resolution mode. And as you'd expect, in the utility menu, it's got a whole bunch of stuff for setting up the LAN network, File Explorer. You can explore the USB stick or the internal memory. You can set up the clock and preferences like that. You can also go into the service menu. It's got a hardware self-test, user calibration, front panel test allows you to test all the buttons and the controls, and the user calibration status, it tells you when it was last calibrated and the difference in temperature and on your serial number and all that sort of stuff. And it's got a whole bunch of other functions which, if I went through them all, it'd take a couple of hours instead of an hour for this review. One feature I really think's missing on this scope that is in the $400 Rigol is digital input filtering of the input signal, so you could actually set up digital filters. Now, that would have been easy to implement in such a high-end scope like this. They might have even been able to do it in the ASIC, but they've chosen not to add any filtering capability at all, and I think that's a bit of a shame. One thing I'm not really a fan of is the persistence mode on the display. If you change to horizontal like that, look, it doesn't clear the display. So you've got all that information there that actually has no correlation at all to the current time-based setting that you've set. Other scopes that I've used, including the Rigol, they will actually reset the persistence whenever you change the horizontal. And the same thing goes for the vertical as well. So just how quiet is this fan? Well, I've got my audio level meter here, and let's try out the Rigol. Almost about 60 dB. It's a good 10 dB quieter. Let's take a look at some of the specs. You can see all the different model numbers they've got across here, 12 of them. Why they've done that, it's crazy. Get rid of the 70 megahertz model. It's nuts. Anyway, yeah, they come in 2 and 4 channels, of course. 1 gig sample per second per channel guaranteed, but it goes to 2 gig samples per second interleaved if you're only using 1 channel. They've all got 100K points memory, which is excellent. They've all got the 8.5-inch display with 64 levels of intensity. They've all got 50,000 waveforms per second. They've all, it's an 8-bit converter, of course. The vertical range goes from 2 millivolts to 5 millivolts per division, and there are an asterisk on there, but that does not limit the bandwidth. The bandwidth is still as claimed for the lower vertical scales, which some scopes, once you get down to the 2 millivolt range or the 10 millivolt range, they can actually lower the bandwidth, but this scope doesn't. And there's that input coupling I was telling you about. It says it does ground, but it doesn't. There's no option to actually do that. The logic analyzer part of it is 1 gig sample per second, which is excellent. It supports all the standard stuff, and you can use it to define the individual trigger levels in 10 millivolt steps, which is excellent. It does plus minus 10 volts on the probe. It's you need at least 500 millivolts before you can do anything at all. 100k input impedance, pretty standard stuff. And maximum detectable pulse width is 5 nanoseconds, so that is a lot different from the analog section of the scope. And the glitch capture on it is excellent. It's 500 picoseconds, as you'd expect from the 2 gig sample per second, and that's at all time-based settings as well. And the high resolution mode, you get 12 bits resolution when it's greater than 20 microseconds per division, and the rearm time for the segmented mode, 19 microseconds if you're keen in that sort of stuff. And the function generator's got extensive specs as you'd expect, but it's basically 0.1 hertz to 20 megahertz, amplitude flatness plus minus 0.5 dB, harmonic distortion 1% minus 40 dB, all pretty standard sort of stuff for this class of 20 megahertz function generator. The square wave jitter is 500 picoseconds. The rise and fall time is 18 nanoseconds. I would have preferred a faster rise and fall time to that, but that's what you get with these sort of generators. So the verdict on the new Agilent 2000 series scopes? Well, in a word, awesome. And do they live up to the bold claims that they redefine the oscilloscope market? I think there's quite an element of truth to it, yes, because, God, 50,000 waveform updates per second for just over $1,200 is absolutely remarkable. I compared this to a 3000 series Tektronix unit, which costs 4 times the price, and it's only got 3,000 waveform updates per second. And I compared the update capture rate on the same signal, and this is an order of magnitude better, and 10 times better, 10 times quicker. It's just phenomenal. It's so responsive. Agilent have put a hell of a lot of thought and effort into these scopes, and I think it's fantastic. And the fact that they've gone back in-house and done everything themselves without rebadging their low-end units is a fantastic step forward. And I do think it's a bit of a shame that they crippled some of the options in here which they could have put in, like the ARB generator and maybe some digital filtering and stuff like that. I don't know, they're conscious design decisions, perhaps, I don't know, but anyway, I think they could have gone a hell of a lot further with this. They need to drop the 70 megahertz model. I don't see the point in it, go for 100 megahertz minimum. So they aren't quite down at the, the $400 price point where, some of the low-end Rygols and other scopes are at, but that's not the market. This is phenomenally better performance for really not that much more money. I mean, just over $1,000 gets you this capability, which before, I've had to spend $10,000, $15,000 on an oscilloscope to get this kind of update rate and performance. It's unbelievable. And now it's coming down due to the technology with the new ASIC in this. They're actually bringing the technology into their low-end products. And I can't believe it. And they've really laid down the gauntlet to the competition. I don't think anyone can match them at the moment for phenomenal update rate for the price. It's incredible. The competition's got a lot of catching up to do, let me tell you. Now, the base price of this unit is, recommended retail price is $1,230 or thereabouts US for the 70 megahertz model, dual channel, no logic analyzer, no function gen. And then you start to throw on, here's where the catch is. They start out, the base price is very, very attractive and it's incredible value for money. But then you start paying, okay, $500 for the waveform generator option. You can go out and buy For $500 you can go out and buy a full-on 20 megahertz arbitrary function generator from another company. You can't buy an Agilent one for that, but you can certainly get fully featured ArbGens for $500. So, you know, it's a bit pricey. The logic analyzer plugin, 8-channel, very nice. Turns it into a beautiful mixed signal scope. I love it. But it's about $700 for that option. You want the LAN capability as well. There's another couple of hundred, I think it's $400 for the LAN module and VGA module. So, and don't mention the bandwidth upgrades, and the Agilent told me really not to tell the exact prices because the exact prices are actually quite flexible depending on the dealer you buy it from and all that sort of stuff. So I don't know what the street price of this thing is going to be for all the various options. It's too confusing, but the options are, I think, a bit expensive, but it is Agilent. So, but the base model unit, unbelievably good value at $1,200. Huge thumbs up. I love it. Now, just because I think the modules are a little bit pricey doesn't mean that the upper model units are not superb value for money as well. If you take a look at the 4-channel 200 megahertz model, then it's around $2,600 retail. Probably goes for a bit less than that on the street. But if you compare that to, say, a Tektronix 2000 series, also 200 megahertz 4-channel model for effectively the same price, it blows it out of the water. It really does. No contest at all. Even if you start comparing it to, say, a Tech 3000 series model, which I don't think they actually compare this one to. I think they're the next model up in this, but this still rings around that, as I've said before, and it's just, God, I don't think there's any contest. These are superb value for money. A winner. Heck, it's not even much more than a Rigol 4-channel 200 megahertz unit. Unbelievable. Even when you throw in the mixed signal logic analyzer capability, which might take it up to over $3,000, it's still dirt cheap compared to, say, a LaCroix Wavejet series or something like that. Value for money is incredible.